Alright, this video is the second video in a series of videos that really is a review of the first semester of geometry. So, if you did not see the first video, you should go back and watch it because that's where we did problems 1 through 8, where we covered a whole bunch of things. We already did a variety of topics. But now we're picking up and we're going to do another variety of topics, starting with how to prove that these triangles are congruent. So, keep in mind that there are 5 ways to prove triangles congruent. We could do side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. Hold on, I don't like the little A I put. I feel like I could do better. Okay, those are the 5 ways. So let's see, we're given that B is the midpoint of AD. Okay, great. But look, because B is the midpoint of AD, that means that BD and AB will be congruent. So we have to record that information on the proof. So we can go ahead and say that DB is congruent to AB. And that's just the definition of midpoint. Okay? When you're asking yourself what the reason should be, look at the previous statement. B is the midpoint. So it's no surprise that the next reason is going to be a definition of midpoint. Okay. But they've given us more information here. AD is perpendicular to BC. Alright, so I'm definitely just going to put given, because that's given. Okay. But what does that mean? Perpendicular means that they form 90-degree angles. But we have to write that down. So we will say angle DBC and angle ABC are right angles. And that's just a definition of perpendicular. Again, if you want to know the reason, look at the previous statement. Perpendicular, definition of perpendicular. That's very common. Alright, but right now we don't have a congruence statement. We just have the fact that these two angles are 90-degree angles. We have to say they're congruent now. DBC is congruent to ABC. And that's because right angles are congruent. That's really a really short theorem, but you can just write down the whole theorem because it's so short. Right angles are congruent. Okay? So, I'm looking to build up to one of these. Is there anything else on, that's the end of the given. Is there anything else on the picture that I can mark congruent that's not already marked? I'm hoping that you're noticing the shared side that we have right here. When there's a shared side, obviously it will be congruent for both triangles. So we can say segment CB is congruent to segment CB. Alright? And when you have something congruent to itself, that's going to be the reflexive property. Alright? That's the reflexive property. Alright, now it looks like we're ready to say that the two triangles are congruent. Which one of these 5 things is it? Well, it looks like I have a side, I have 2 sides, and the angle that's in between. So that's going to be side, angle, side. 2 sides, and the angle in between is side, angle, side. All right, moving on to number 9, part B. So we are given that BD and AE bisect each other. BD, AE. That means they cut each other in half. So that means that BC will be congruent to CD, and that AC will be congruent to CE. Okay, and that's just called the definition of bisector. Well, definition of segment bisector. Definition of segment bisector. Definition of segment bisector. Again, if you want to know what the reason is, you should start by looking at the previous statement. BD and AE bisect each other. That's why it's definition of bisector. If this mentioned a midpoint, it would probably be definition of midpoint. Anyway, let's keep going. Well, that's the end of the given. But this is not enough to prove the triangles are congruent. Is there anything else I can mark congruent? Sure, I've got these angles right here in the middle. Bam! These are vertical angles. So I can say angle BCA is congruent to angle DCE. And that's just because vertical angles are congruent. So now I have enough information. These triangles are congruent by side, angle, side. You can tell because I have two sides and the included angle. That's two sides and the angle in the middle. Alright, moving on to number 9, part C. Okay, we are given that angle B is congruent to angle E, so kabam. Alright, so given. We're also given that BC is congruent to EA. So BC is congruent to EA. Also given. We're also given that angle C and angle DAE are right angles. So I'm going to mark these. But so far I've only said that they are right angles. I haven't said they're congruent. Alright, the other two statements I said this is congruent to that. This is congruent to that. So we really need that congruency. So that's what I do. In the very next step I have to say angle C is congruent to angle DAE. So these are kind of a pair. This angle and this angle are right angles. This angle is congruent to that angle because right angles are congruent. Right angles are congruent. Alright, so you will see these two statements together all the time. So now we're ready to say that these two triangles are congruent by angle, side, angle. So we have two angles and the included side. Two angles and the side in the middle. This time they're leaving us to make the congruence statement ourselves. So triangle ABC is congruent to triangle, let's see, ABC, DEA. Okay. Well, normally we'd be done right now because we've already proven the triangles are congruent. But oh no! I look and I realize that actually I realize that they didn't say. Oh, okay. I started to say they didn't tell us what we were supposed to prove. That would be a little difficult, but it looks like it's just some bad formatting and it just wound up on the next page. So we're supposed to prove that A is the midpoint of CD. Okay, so let's work backwards. What would it take for A to be the midpoint of CD? Let's see. If we want to show that A is the midpoint, let me change colors. If A is going to be the midpoint, that means that CA has to be congruent to AD. That's what it would take for A to be the midpoint. All right, it would have to be equal on either side. So before we can get to A being the midpoint, we first must have these two segments being congruent. So that's what we need to write down. CA is congruent to AD. And they were very nice and gave us the reason, CPCTC. Please remember what this stands for. CPCTC. Try to take a second and really absorb what this means. Corresponding parts of congruent triangles are congruent. It's saying if we have congruent triangles, if you look at any corresponding parts, of course, they will be congruent. So that makes sense because in this step right here, we just proved that the triangles are congruent. That means any corresponding parts will be congruent, including CA and AD. So these corresponding parts will be congruent because corresponding parts of congruent triangles will always be congruent. CPCTC. Okay, fine. So now we have these two halves on either side. The two segments are congruent. That means that A is the midpoint. So we get to now say A is the midpoint by the definition of midpoint. And that's it. Alright, number 10 has a lot of parts to it. The main thing is that this is a rectangle. And one thing we know about rectangles is that the diagonals bisect each other. In other words, and you know what? And the diagonals are equal. Not only do they bisect each other, but they are also equal. That means that all four of these segments are congruent. So keep that in the back of your mind. But you know what? I think we'll come back to that later. Let's deal with the angles first. Alright, and then we'll deal with the segments second. So they say that angle SQR is 68. So let's see, SQR, that's this angle right here. Okay, so that is 68. Okay, now let's play around. Let's see all the angles that we can find because of that. So let's start with this. I see an N shape, kind of like the letter N. Alright, it might be a little upside down or something. Or you can look at it as a Z that has fallen on its side. But the point is, since QR and PS are parallel, then these alternate interior angles will be congruent. So this will be 68. Okay. What else do I know? Well, remember that the corners of a rectangle are 90 degrees. So, if this is 68 degrees, I can easily figure out what the other side must be, because it's got to add up to 90. They got to be complementary, if you will. Okay, so I can go 90 minus 68. Whoa, not 590. 90 minus 68. And that's 22. So that tells me that this little guy right here is 22. And the same math would happen over here, so that means that this is also 22. And then let's use isosceles triangles. So a minute ago I was mentioning that all of these segments are congruent to each other. So for example, these two segments are congruent to each other. That makes this an isosceles triangle. Alright, that means that S and P, those two angles are the same because it's a sort of a sideways isosceles triangle. So that means that this is 68. And check it out, we have another isosceles triangle over here. Bam, bam. So if this is 68, then this is 68. So these are all 68s in here. Similarly, looking at it the other way, alright, this and this. Alright, this is an isosceles triangle. So I'm going to have 22 and 22. And this is an isosceles triangle. So this is also going to be 22. Alright, so we got all those angles in there. While I'm at it, let's go ahead and find the angles on the inside, because why not? Let's start with the 68s. These all have to add up to 180. So if I take 180 minus 68 minus 68, that's 44. That tells me that this little angle right here is 44. Vertical angles and such, so this is also 44. I could do the same thing with the purple angles. Okay, I could take 180 minus 22 minus 22. That's going to be 136. And this will be 136. Okay, I also could have used the fact that I have a straight line here. I could have subtracted 180 minus 44. That would have been the same thing. Alright, we found every possible angle in this picture. So which ones did they actually ask us for? The measure of angle PQS. Let's see, PQS, that's one of these purple ones. Alright, that is 22 degrees. The measure angle PRQ. So PRQ. That's this 68 right here. And the measure angle QTR. QTR. That's this 48, one of my vertical angles. Okay, that's great. So I'm kind of done with the angles now. So I'm actually going to go back and erase all that. And now I'm going to deal with the segments. So remember, these segments are all congruent. Okay, congruent, 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 congruent. Those are all the same. Now PR is 18. So watch this very carefully. PR, that's all of this, is 18. So T is right there in the middle. So if PR is 18, that means that it's 9 and 9 on either side. And I just told you that all four of these segments are the same. So guess what? They are all 9. 9, 9, 9, 9. They're all 9. Okay, let's see if they simply ask us for these. PT is 9. Boom. What about QS? Ah, QS is the whole thing. So that's going to be 18. And then they asked me for TQ. TQ is another 9. It's like half of one, half of a diagonal. So that's back to the 9. Alright, the next few problems refer to this diagram. Now for number 11, it says, use the list from number 3 as a word bank. Don't bother looking back at number 3 to see if there's a word bank there. There's not. This was cut and pasted from something else. So I guess here's your word bank. And on the test, you won't have a word bank, so you better just have these memorized anyway. So just remember what corresponding angles are: alternate interior angles, alternate exterior angles, consecutive interior angles, linear pair, and vertical angles. Just remember what all those kind of look like. So what do we got? Angle 1 and angle 7. You better know those, man. Angle 1 and angle 7 are definitely vertical angles. Don't abbreviate these. Vertical angles. When we're doing proofs, we abbreviate all these things, but this is one little spot where I need to see that you know your vocabulary, so do not abbreviate. Angle 2 and angle 3. So angle 2 and angle 3 are these angles right here. Alright, see how they're between the lines? That means they are interior. See how they are on the same side? That means they are consecutive. So these are consecutive interior angles. Okay, and here they are in the diagram, alright, in the notes. By the way, this image that I'm looking at, for those of you who are actually in my class and not just on the internet, this is the day 2 notes. Anyway, number 4 and 8. Okay, let's see. So here's number 4, here's number 8. So these are outside of the parallel lines, so that means they are exterior. They're on opposite sides of the line, so that means they are alternate. So we will say these are alternate exterior angles. Okay, and then finally 5 and 7. Alright, so here's 5, here's 7. Alright, these are both in the same position. See how this is in the, if you look at this cluster, angle 7 is in the lower right hand corner. And if you look at this cluster, angle 5 is in the lower right hand corner. When they're both in the same position like that, they are called corresponding angles. Or in later units, we talked about how there's a letter F in here. When I first taught this, I never mentioned the F, but I mention it these days, so maybe I'll mention it now. Do you see the F right here, guys? Boom. When you have an F and the angles are in the corners of the F, that's another way of knowing that these are corresponding angles. Okay. Moving on to number 12. Suppose that P and Q are parallel. So notice we are not given that they're parallel in the diagram. When two lines are parallel, they can indicate that by putting some arrows on there like this. Alright, so now if they're parallel, then a lot of these angles are going to be congruent. Let's look back in the notes. For example, corresponding angles are congruent. Alternate interior angles are congruent. Alternate exterior angles are congruent. However, consecutive interior angles like these are supplementary. So watch out for that. So let's see. Angle 8 and angle 6. Alright, here's angle 8 and here's angle 6. Those are corresponding angles. Alright, they are going to be congruent if the lines are parallel. So that means that 10x minus 6 should equal 6x plus 50. And we will solve this out by subtracting 6x from both sides. So that's going to leave 4x minus 6 is equal to 50. And then we add 6 to both sides. So that gives us 4x is equal to 56. And then we divide by sides by 4. So what's 56 divided by 4 again? I don't rightly know. 14. So we find out that x is equal to 14. Kabam. Okay, so now, again, supposing that P and Q are parallel, take a look at angle 2 and angle 3, and let's see if they're congruent or supplementary, which is kind of pretty much the two options that we have. Okay, angle 2 is right here, and angle 3 is right here. Alright, those are consecutive interior angles. Those are definitely going to be supplementary. Alright, many of these angle pairs are congruent. Looking at the notes, congruent, 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 but this one is supplementary. That means they have to add up to 180. So I'm going to make this little equation that says 4x plus 12, okay, plus 5x plus 6 must equal 180. So combining like terms, I'm going to have 9x plus 18 is equal to 180. And then I subtract 18 from both sides. So I'm going to get 9x equals 162. And then I divide both sides by 9. And I get 18. So x is equal to 18. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.